Okay, so we're going to do a couple more examples on compound inequalities. And so in this example, we're going to try to manipulate our compound inequality so that we could find certain values. So for instance, let's say that you have -4 is less than x is less than 0. And then a is less than 1/2 x is less than b. So we want to find a and b. If this inequality holds true, -4 is less than x is less than 0, then what is a, which is less than 1/2 x, which is less than b? What is b? So basically on this, all we're trying to do is to manipulate what's in between the two inequalities to look the same. To look like what we have over here. And so I noticed in order to get a 1/2 x in here, I have to multiply this by a half. But if I multiply this by a half, I have to multiply each inequality, each side of the inequality by a half. So if we go through and we multiply this by a half, so kind of think of it as distributing, or basically I'm multiplying this to each side of the inequality. So -1/2 times -4, well, that's just -2, is less than 1/2 times x is 1/2 x, which is less than 0 times 1/2, which is 0. So notice now that we just manipulated the middle piece of our inequality to look like what we were asked to get. And so we could say that A is going to equal
Yo estoy haciendo matemáticas y ella está haciendo.
-2, and then B would equal 0. Okay, so what if it had been same kind of example where you're finding A and B, but this time we have 0 is less than x is less than 4. And we want to find A and B such that A is less than 2x plus 3, which is less than B. So same kind of idea. We want to be able to manipulate what is inside this x in between the 0 and 4 to look like this 2x plus 3. And so we have to think to ourselves what we can do to manipulate that to look like that. And so up above, we have multiplied everything through by 1/2 in order to get that 1/2 x. So notice if we multiply everything by 2, we can get at least part of this piece in between. We can get 2x. So let's multiply every single term by 2. So we have 2 times 0, 2 is less than 2 times x, which is less than 2 times 4. So 2 times 0 is 0. This is less than 2x, which is less than 8. So it's not quite the same as what we have in between the A and B up here. And so in order to get that plus 3, and we can do this because they're inequalities, we can just add 3, in this case, to all 3 sides. So if we do that, we have zero plus 3, which is 3. So 3 is less than 2x plus 3, those are not like terms, which is less than 8 plus 3, which is 11. So looking at this, hopefully you can see that a is equal to 3. And our b value is equal to 11. Okay. So let's look at one more. What if you have is 2 is less than x is less than 4? And we're looking at then a is less than 1 over x minus 6, which is less than b. Okay, so again, we're trying to manipulate the in between those inequalities, that x. This time we're trying to manipulate it to look like 1 over x minus 6. So any ideas on what we could do to manipulate that to look like this? So we looked at properties yesterday. Maybe Mohammed, did you have something to say? Sometimes I need to pause a little longer. We had talked about some properties yesterday of reciprocals and inequalities. And so I noticed I can use that or some of those properties to rewrite this as 1 over x. But if I do that, I don't have this minus 6 in there yet. And so let's first start by getting this to be x minus 6 in between the inequalities. And so we could do that by subtracting 6 on all sides of those inequalities. So in this case, we would subtract 6, another way to write this, subtract 6. And so now we have 2 minus 6, which is negative 4, is less than x minus 6, which is less than 4 minus 6, which is negative 2. So notice both of those values are less than 0. And so when we take the inverse, when we take the reciprocal, that's going to change the direction of these inequalities. So let's take the reciprocal of everything. So basically, negative 4 becomes negative 1 over 4. But that changes, again, the direction. So this is now becoming greater than the reciprocal of x minus 6. We'll treat that as a grouping x minus 6. So bringing that down to the denominator, we get 1 over x minus 6. Change the direction of our inequality, so that now makes it greater than. And then negative 2 would become reciprocal as negative 1/2. Okay, so usually with compound inequalities, you don't see the inequalities written this way. So let's just rewrite it. So let's rewrite it because negative 1/2 is the smallest value. So negative 1/2 is less than 1 over x minus 6, which is less than negative 1/4. So as long as we can rewrite this, it's equivalent as long as, if some people call this the mouth of the alligator, is opening up towards the same direction. So this -1/2, it has a less than 2 piece, a smaller piece, same direction here, greater here. Same thing. This has the greater piece on the -1/4. Over here has the greater piece on the -1/4. So we just were able to find what A and B were. So A is equal to what was on the left. So A is equal to -1/2. And B is going to equal -1/4. Oops. Okay, so I just wanted to go over those couple examples. Actually, I want to do the challenge problem too. So I was a little disappointed yesterday when I was lecturing because I didn't see this type of inequality, and then later I saw it as one of the challenge problems. And so this is probably something maybe you haven't seen with compound inequalities before, but when we, so far in this class and probably other classes that you've had, is the variable is always just in between those two inequalities. So what do you do if you have variables on each side of those inequalities? If it was just a single inequality, then we can move things around. But if it's a compound inequalities, there's multiple inequalities in there, then you have to be careful. So for instance, let's say you had x minus 4, and then we have less than 2x minus 3, which is less than or equal to x plus 5 all over 3. Okay, so we're trying to find all values of the x that would make that statement true, that inequality true. So again, we have a problem because we can't manipulate this right now how it's written and get the variables just in between these two inequalities. But by definition, maybe I should write this. I'm going to do it on the side. By definition, if you have A is less than X is less than B, basically what this is saying is A has to be less than X, intersection, and X has to be less than B. It's the set both of these sets have in common. Okay, so by this definition, we can break this compound inequality up into two separate inequalities. And then once we solve those two separate inequalities, we're going to look at what do they both have in common. Okay, so rewriting this, I have one inequality, which is x minus 4 is less than 2x minus 3. And then I have the inequality that 2x minus 3 has to be less than or equal to x plus 5 all over 3. Okay, so each inequality, we're going to solve them separately, but each inequality is a linear inequality. And so we solve those by just solving it like it was an equal sign. Only thing we have to worry about is multiplying or dividing by a negative. So I tend to like to get x is always on my left-hand side. And so for this first inequality, we want to get x by itself on the left and the constants to the other side. So let's subtract x on both sides. So let's subtract 2x on both sides. So minus 2x to get x's on the left. And then let's add 4 to both sides. So if we do that, we have x minus 2x. That gives us negative 1x. 4's cancel is less than negative 3 plus 4, which is 1. Multiply by a negative, flip the sign. So now it's a greater than sign. So negative 1 times x is negative 1 times negative x is positive x, is greater than negative 1 times 1, which is negative 1. Okay, so let's just graph that really quick down here. So that was the piece, x is greater than negative 1. So if we drew that picture, we would find negative 1 on our graph. And it's everything that is bigger than negative 1. So it's everything shaded to the right of that. And I'm just going to do it above my number line for now, because that's not really my solution. That's going to help me get the solution. And we use a parentheses because it was strictly greater than. It didn't include the negative 1 in there. So now let's look at that second inequality. 2x minus 3 is strictly less than or equal to x plus 3. So I don't like that there's a fraction. And so we can clear that fraction by multiplying both sides by your least common denominator. Well, there's only one denominator. So let's multiply both sides by 3. So if we distribute our 3 times 2x is 6x. 3 times negative 3, so minus 9, is less than or equal to. The whole reason of doing that was so that fraction went away. So make sure you cancel that. You're not distributing the 3 to that numerator. You're just left with x plus 5 on the right of the inequality. So get terms with x on one side, terms without x on the other side. If we subtract x on both sides, add 9 to both sides. 6x minus 1x is 5x. This is less than or equal to 5 plus 9, which is 14. Get x by itself, we want to divide by 5. We're dividing by a positive, so we're okay. And so x is less than or equal to 14/5. To me, it makes a little more sense if I figure out what 14/5 is. 5 goes into 14 twice with a remainder of 4. Okay, so 2 4/5. So locate 2 4/5 on our number line. And it's everything that is less than or equal to 2 4/5. So it's everything that is shaded, that just that piece is everything that is shaded to the left of that 2 4/5. And it has the equal to part to inequality, so we're going to have a bracket. So our solution, because it's an and statement, it's what they both share in common, what both of these sets share in common. You have to look at where they overlap. And they overlap, notice, between -1 and 2 4/5. So our solution So we're starting at -1. I'm not going to put the bracket or parentheses yet, comma, and we're ending at 2 4/5. I'm actually going to leave it as 14/5. Which is the same thing. And then determine what type of notation, parentheses or brackets. Well, x is greater than -1. That actually does not include -1. The other set does, but they both have to include the number. So we're going to use a parentheses. 2 4/5 is included in both sets, and so we need a bracket here. So we could write it like that, or another way to write it in interval, sorry, that was interval notation. Inequality notation is -1 is less than x, which is less than or equal to 14/5. So you might have seen, I noticed they use set builder notation in here. All that is basically using set notation. Set notation, I call them curly brackets. So it depends on what variable you're using. Here we're using x, so I'm just going to put an x here. After you put the variable that you're using, you put a vertical line always. That vertical line means such that. And then you put the stipulation that x has to be. So it's the set of x such that, well, define what x has to be. Well, we have it defined up here. X has to be in between, it's our inequality, -1, which is less than x, which is less than or equal to 14/5, or you can write it as 2 4/5, or 2.8. So these are all different ways to write the same thing. Okay, so let's move on. I'm going to just change the page. And we're going to get into absolute values and absolute value equations and absolute value inequalities. Okay, so again, we're looking at absolute value equations and inequalities. Okay, so absolute values are notated by those two vertical bars surrounding whatever you're taking the absolute value of. So for instance, if you took the absolute value of 5, what do we get back? If we took the absolute value of -5, what would you get back? So by definition, absolute value is just the distance between, if you were looking at 0 and that number on the number line, and you counted how many marks you'd have to go from 0 to that number, distance is positive, that's what that would be. So basically, absolute value of 5 is just 5. And the absolute value of -5 is also 5. So by definition, and we're going to be getting into piecewise functions maybe this week or next week. By definition, f of x is equal to, if you have a function, f of x is equal to the absolute value of x. This is defined, well, there's two different values that you can get, and it depends on what x is. If x is bigger than 0, actually even equal to 0, you're going to have the same value that you would have had if you plugged it in there. If you plug in a number which is smaller than 0, in order to figure out what you would get back, well, if you plugged in -5 here for x is smaller than -5. In order to get back a +5, well, you would have had to take the negative of the negative. So the result would be -x. So if we were looking at, by definition really, f of x, how about f of -20? So you would go over to your piecewise function, figure out what that fell in, which inequality. Well, is -20 bigger than or equal to 0? And it's not. And then, so -20, is that smaller than 0? It is. So it flags you to use this piece. And so when you plug in -20 wherever you see an x, you get that negative of -20. And negative of -20 is equal to +20. So if you chose a number 10, you would look at, okay, which set does it fall in? Is it bigger than 0 or less than 0? 10 is bigger than 0. You'd plug it into just x, and that would give us 10. So technically, I know you probably have been doing absolute values, but you might not have seen it written as this definition. Okay, so that being the case, how are we going to solve absolute value equations? So having equations that have absolute values in them. So if you had the absolute value of x, it was given to you that it was equal to 5, what could x be that would make that a true statement? So what could you plug in for x that would make that true? So as an instructor, I'm always reading and trying to become a better instructor and going to conferences and stuff. And they tell us as instructors, we answer our questions way too fast. We don't allow time for our students to answer. And suggest that you just stop and don't say anything or don't answer it. And usually along silence, someone will eventually say something. So I'm going to do that.
5 or -5?
Yay, see, I knew it would work. And I knew it would be faster if I gave you that little story maybe, or spiel. Okay, so x equals 5 or x equals -5. Those are two values that we could plug in there and we could get back 5. So there's actually two solutions here. We can make this more generic because maybe it's not just x inside that absolute value, or maybe we have some other things going on than just a constant. So if you have the absolute value, let's see how they do it. Sorry. didn't really do it. Okay, so if you have the absolute value, I'm going to do capital X, is equal to A. Then the following thing holds. Either whatever is inside that absolute value is equal to A, or whatever is inside that absolute value has to equal negative A. There has to be one stipulation in here because it wouldn't work. So as long as A was, as long as A is greater than or equal to 0. Right? So for instance, and this is why it wouldn't work if it was less than 0. For instance, if you had the absolute value of X is equal to negative 5, there's no number we can put in and take an absolute value of it and then get back a negative number. So this is impossible. Which means no solution. Okay, so we can kind of use this to help us solve absolute value equations. Let me just see. So let's say you have the absolute value of 2x plus 3, and that absolute value is equal to 5. So first thing you want to do is you want to rewrite it without absolute values. And so to do that, by definition, then 2x plus 3, there's two separate equations, is either going to equal positive 5 or 2x plus 3 could equal negative 5. And then just solve them separately. Well, we have a linear equation, and so we go about that isolating the variable. So subtract 3 on both sides, we get 2x. 5 minus 3 is 2. Divide both sides by 2, we get x is equal to 1. Subtract both sides by 3 here, so we have 2x is equal to negative 5 minus 3 is negative 8. Divide by 2 on both sides, so you get x is negative 4. So basically, if you plugged in 1 for x back in the original equation and you simplify what's inside that absolute value, you get the absolute value of 5 is 5, true. If you go back into that original equation and you plug in negative 4 wherever you see an x, 2 times negative 4 is negative 8, plus 3 is negative 5. Absolute value of negative 5 is positive 5, so true. So we have two separate solutions. So most common error is students only give me one solution because they only drop it and don't drop it and set it equal to the negative of the other side. So if you have the absolute value of x squared minus 2x and the absolute value is equal to 3. Okay, so in order to solve the absolute value equation, you want to set it up as two separate equations. Both of the examples we started with already had the absolute value isolated. If there were other terms with this absolute value on the one side of the equation, I would manipulate it and first isolate the absolute value before I dropped it. Okay, so in this case, both cases that were already done for us, so I didn't have to worry about this. But right now, dropping the absolute value, I have x squared minus 2x is equal to positive 3. Or it could be the case that x squared minus 2x is equal to negative 3. So you want to solve each equation. You should recognize it's quadratic, and in that we need to get this set equal to 0. So let's subtract 3 on both sides for the first equation. And so we have x squared minus 2x minus 3 is equal to 0. You want to factor. So there are two numbers that multiply to negative 3 and add to negative 2. So two numbers would be negative 3 and positive 1. So x minus 3 all times the quantity x plus 1 equals 0. Set each factor equal to 0. So you should be able to see x minus 3 is 0 and x is 3. X plus 1 is 0 and x is negative 1. And so now do the same thing with that second equation. We want to solve this. It's quadratic. Get everything to one side. So we get x squared minus 2x, adding 3 to both sides. So plus 3 equals 0. And this is where I'm like, ugh, there's no two numbers that multiply to positive 3 and add to negative 2. There are no integers. So it's either complete the square, which I don't want to do, or use my quadratic formula. So x is going to equal negative b. Negative of negative 2 is 2 plus or minus the square root b squared, which is 4, minus 4 times a is 1 times c is 3. All over 2 times 1 is 2. So 2 plus or minus the square root. 4, well, this is order of operations multiplication first. 4 times 3 is 12. So 4 minus 12, that's a negative number. 4 minus 12 is negative 8. All over 2. So x is equal to 2 plus or minus, just so that we get used to this. We can break this down. Well, negative 8 is the same thing as negative 4, which is 2i. And then we're left with a 2 under the radical, all over 2. Technically, you could have stopped there, but again, kind of review what we were doing yesterday with complex numbers. So just kind of helpful. We can factor out a 2 in the numerator, which would leave you with 1 plus or minus I root 2, all over our denominator of 2. Those 2's cancel, which kind of makes it look like an x. And so you're just left with x equals 1 plus or minus I. Root 2. And if you looked at the example, and that's why I said we could stop, it says find the real solutions, if any, of each equation. And so notice this is not a real number. We talked about that R meant real numbers. And so the only solution, and really you technically should check, especially if there was a variable over here, because it might not work, but it does work. 3 squared is 9, 9 minus 2 times 3 is 6, 9 minus 6 is 3, absolute value of 3 is 3. Plugging in -1 squared is 1. -2 times -1 is +2. 1 plus 2 is +3. Absolute value of 3 is 3. What if you had the absolute value of x squared minus 2x? And that absolute value is equal to the absolute value of x squared plus 6x. Okay, so we have multiple absolute values. One of them is it's so that one is isolated. Well, basically, if what's inside the absolute value, this x squared minus 2x, gives me the same number that x squared plus 6x would have given me when I plugged it in, then that would have to be a solution, because that same number in the absolute value equals the same number in the absolute value. So one way that we can find the answer is x squared minus 2x has to equal the same thing over here, x squared plus 6x. That value of x works and makes that a true statement, then the absolute value of those things would make a true statement. But also the negative of one of these. So if one of these answers in here, the value of x gave us the negative of a number, and the other one was the opposite of that, taking the absolute values of both of those would give us the same number. So if there's more than one term on the other side of the absolute value sign, or another absolute value, you have to set that equal to the negative of that whole thing. So we're looking at when is x squared minus 2x equal to the negative of the whole quantity on the other side, which is x squared plus 6x. It technically doesn't matter which side you put that negative, but it has to go around that whole quantity. I technically could do the same thing here. I could have put negative here and kept this one positive. But if I multiply both sides by -1, I'd get the same result. So it doesn't matter. Okay, so looking at the first equation, I notice it's quadratic. So I would try to get everything to one side of the equation, but once we move over the x squared, notice they go away. And so then we're just left with -2x then has to equal 6x. So get x's to one side of the equation. If we subtract 6x on both sides, we get -8x equals 0. Divide by -8, well, x is equal to 0 over -8 is just 0. So solve the other equation, x squared minus 2x. That negative outside the parentheses, though, has to be distributives, like -1 times the whole thing inside. So this gives us minus x squared. And a minus 6x. So again, it's quadratic. So if we add x squared to both sides, it actually doesn't cancel the quadratic. So getting everything to one side of the equal sign So let's add 6x also on both sides. We get x squared. Negative 2x plus 6x is positive 4x is equal to 0. So we want to factor. I notice they both have a greatest common factor of x. So if we factor an x from both terms, we're left with x plus 4. And that quantity is equal to 0. So we're looking at when is x equal to 0? And when is x plus 4 equal to 0? And that's when x is negative 4. So we actually have only two solutions because x equals 0 here and x equals 0 here. We don't have to list that twice.
Professor, I think you forgot the 2 for x squared plus x squared.
Oh, I did. Yay. Thank you for catching that. X squared plus x squared is 2x squared. So really, when we factor it out, we're going to pull out a 2x there. And so we'd be left with a single x plus a 2 equals 0. So 2x is equal to 0, still when x is 0. And x plus 2 now is equal to 0 when x is negative 2. And so if you checked it, it would work. Plug in 0 for x. Well, absolute value of 0 on the left equals absolute value of 0 on the right. Negative 2 quantity squared is 4. And this would be plus a 4. So absolute value of 8. Negative 2 squared is 4. 4 minus 12 is negative 8. But the absolute value of negative 8 is the same thing as the absolute value of positive 8, which are both 8. So they both work. Okay, so I would have noticed something was wrong going back in there and plugging in that number, and I would have had to gone back and check. So there's another reason why checking is also beneficial. Okay, so those are with equations. So what do we do when it's absolute value inequalities? And so there's a couple rules for inequalities. So in order to drop absolute values for inequalities, you have the following rules. And it depends on what way or what direction that inequality is facing. So absolute value inequalities. So if you have some absolute value, and I'm just going to make it a big capital X again because it could represent some function other than just some X. And let's say that it's less than or equal to, it doesn't matter if the equal to part is on there or not, some value of A. In order to drop that absolute value, we want to sandwich this value of X, absolute value of X, or whatever's inside. We want to sandwich it in between the negative and the positive of the other side. Oops, I'm just going to capital it. And sometimes, again, it's helpful just to think about a little bit of an example. So let's just, a simple example, let's say X is just less than 2. And again, it doesn't matter if it has a less than or the equal to. Well, this is saying that I would choose any number between 2 and negative 2, and that would work. So if I chose any number in between negative 2 and 2, so 1 is in between those, notice that works. Let's try it differently though. Let's try choosing a number that is not in that set of the solution. And so let's choose something that is not between negative 2 and 2 and see if that's a true statement or not. So if I chose 5, absolute value of 5, if I get rid of the absolute values, I'd have 5. 5 is not strictly less than 2, it's false. And so this is how you're going to solve it if it has a less than or equal to. So our solution in here is -2 is less than x is less than 2. The other direction, if it had been a greater than absolute value inequality, so if you had some value, absolute value of x is greater than or equal to some number, then to drop the absolute value, we actually have an OR statement. We can look at any value that's inside that absolute value is less than that negative b, or anything in that absolute value has to be greater than b. This is a union or an OR statement. So it means you're taking everything from this set plus everything that falls in this set, and they don't have to be in common. So again, if you look at a simple example, you can see that that works. So if we said x has to be, absolute value of x has to be greater than, I should say 2. So it says, if you choose any number of x which is less than the negative of this, -2, it should work. So a number less than -2. Well, a number less than -2, well, -3 is less than -2. If I take the absolute value of that, -3, it's +3, and 3 is greater than 2. If I choose any number bigger than 2, well, absolute value of that positive number is bigger than that, so it works. Where if you had chosen a number that doesn't fall in this set, so that would be anything in between -2 and 2, that would give me back something that doesn't work. So for instance, 0 is in between -2 and 2, and the absolute value of 0, which is 0, is not bigger than 2. Okay, so those are the 2 rules that you need in order to solve absolute value inequalities. And again, it depends on the direction the inequality is facing, depends on which way you're going to use it. Let me just write this down. So x was less than -2 or union. X is greater than 2. And so real quick, in the interval notation, so this is basically saying you have everything to the left of -2 shaded, and you have everything to the right of +2 shaded and not included. So interval notation, you come in from -infinity going to -2. We're not including -2 because it was a strictly greater than. So parentheses union parentheses 2 comma infinity. Okay, so we have -3. Then we have an absolute value. Inside that absolute value is 2x minus 5 in the absolute value. And you're given this is greater than or equal to -21. So before you drop those absolute value signs, you need to isolate the absolute value first. And so I notice I don't want that -3 in front of my absolute value. And so I need to get rid of that. It's a multiplication in between the -3 and the absolute value. So to get rid of that, we're going to have to divide both sides by -3 or multiply both sides by -1/3. Either way you want to look at it. But we got to be careful because we're dealing with inequalities. And so if I multiply this, or divide this by -3, and divide this by -3. That's going to change this to now less than or equal to. So the absolute value of 2x minus 5 is less than or equal to, now -21 divided by -3 is +7. So to drop, we've isolated the absolute value in order to drop the absolute value because it's a less than. It's sandwiched in between. So -7 is less than or equal to 2x minus 5, which is less than or equal to 7. So our goal is to get this x by itself in between these inequalities. So first up, we would add 5 to both sides, or all three sides. -7 plus 5 gives us -2, is less than or equal to 2x, less than or equal to 7 plus 5 gives us 12. Get rid of the 2 in front of the x. We're going to divide everything through by 2. So -2 divided by 2 is -1, is less than or equal to x, which is less than or equal to 12 divided by 2 is 6. So anything between -1 and +6, and including those, are our solution. Sorry, I thought we were doing I'm just so surprised we're not doing quadratic or rational inequalities yet. Okay, I guess I don't teach you that yet, or review it with you guys yet. Okay, so kind of, again, this book is a little different, but this is a great problem. So, and it's something you'll see in calculus if you're going to be there next semester. If you had x, the absolute value of x plus 2, that whole thing is less than 5. We're going to try to manipulate this such that then a, we're going to try to find a and b again, is less than x minus 2 is less than b. Let's find a and b. Okay, so just like at the beginning of class, our whole goal was to manipulate the inequality we were given to make it look like the middle, to look like the middle in between these two inequalities. Unfortunately, this one does not have two inequalities in it. But by definition, and it's a less than sign inequality, we can rewrite it. So this is the same thing as -5 then is less than, drop the absolute value, x plus 2, which is less than 5. And so our whole goal now is to make this look like x minus 2 and not x plus 2. And so you have to think to yourself, what can I do to each side of an inequality to manipulate that middle piece to be x minus 2? So this is where I'll pause and let you answer that piece. How am I going to make that x minus 2? I can hear my giraffe back there screaming the answer, guys.
Would you multiply the whole thing by -1?
If I multiply the whole thing by -1, and that's a great suggestion, the problem is that that would make this a negative x and a minus 2.
Can you subtract 4 from all sides?
There you go. So subtract 4 on all sides. And that would work. So really, a lot of times in math, you might not have a clue, but you just kind of have to start and try things. And sometimes things don't get you where you want to go, and you got to go back and try it again or try a different way. So, right, 2 minus 4 would give us the -2. And so here, just simplifying each side, we have -5 minus 4, that gives us -9. So -9 is less than x. 2 minus 4 is -2, which is less than 1. And so we've manipulated what we wanted. And so now we can see that A then has to equal -9 and B has to equal 1. Okay, so that is absolute value equations, absolute value inequalities. You just need to remember how to rewrite the equation that you could drop the inequalities and solve, or how you're going to rewrite absolute value inequalities so that you can drop the absolute value signs and solve. So we only have one more section in this book, and it's 1.7, and it goes on to problem solving. Everybody's favorite, right? You don't realize how much of our life is solving problems. Anyways, and coming up with solutions. So really, a lot of times you're doing math in your head and you don't even know it. So let's take a break, and then we'll come back and look at some applications. Pause this. Okay, so we're getting into applications, everybody's favorite, at least that's what I've heard before in the past. And so from this objective, our learning objectives for this piece of the course, so you should be able to translate a verbal description into a mathematical expression. So taking words and rewriting it in mathematics, solve interest problems, solve mixture problems, solve uniform motion problems, and solve constant rate job problems. Okay. So translating an expression or a verbal statement into a mathematical expression. Okay, first of all, when you're doing word problems, first thing you want to do, obviously, is to read through it. Read through it all the way through. You might have to actually go, and then you're going to go back and you're going to read through it. And the second time you're reading through it, you're going to start picking out information that you're given. You're always in these word problems are given enough information that you can solve things. So you might have to recall certain formulas that you've used in the past that are going to help you to solve these equations, but you, again, should be given enough information that you can solve it, which is not always the case when you're working in real life situations. Okay. Anyways, so you're going to read through it, you're going to reread through it, you're going to start picking out the information that you're given and what you know, and then you're going to try to come up with some sort of an equation that's going to help you solve what you're looking for. And so the other thing that you need to be careful or do is look at your answer at the end. Does that make sense to what they were asking you? I mean, if you're talking about distance and you're getting a negative number, that doesn't make sense. And so you need to go back and relook at things. Again, a lot of times in mathematics, it's just getting there and going and starting. You might come across a problem and it looks daunting and you don't know what to do, but you just gotta go with it and gotta start working with it. Applications is something that I used to shy away from, and part of that was because I grew up with dyslexia, and so reading and comprehension was a lot harder to me than maybe some other students. But so if I can do these, I know you guys can do these. So anyways, enough of my kind of pep talk on this. So let's do a couple examples, and I will remind you of a couple of formulas as we go through this. And I should have pulled up things so I didn't have to write them all. But so first of all, so translate the following sentence into a mathematical equation. So it tells us that the area A of a circle is the product of the number pi and the square of the radius. And so again, so the area, comma, A, capital A, of a circle is the product of the number pi and the square of the radius. Comma, R, little r. Okay, that one might not be that hard because you might remember that formula for the area of a circle. Area, capital A. So the area of a circle is, so anytime you see is in there, or a lot of times when you see is, that means equals. So equals in mathematics is the product of the number pi. So product, to me, that means multiplication. And multiplication of the pi, so I need to put pi in there. And so it's telling me what I'm multiplying. Pi and the square of the radius r. So equals pi, that product, so times the square of, that tells me it's an exponent, r squared. Let's see if I can come up with a. Okay, so here is where students tend to get mixed up on. So could you write the following? What is the difference between a number decreased by 8 and 8 decreased by a number. Okay, so those are very similar, but definitely different. So decreased is telling us that we're doing what? And I saw you guys were answering questions and I just didn't see the chat box.
Subtracting.
Yeah, so subtracting. So a lot of times it's in the order that it's saying it. So a number decreased by 8. So a number, it's being decreased. You're taking away 8 of it, minus 8. We're here, and so maybe I shouldn't write that as a number like that. So and a lot of times we'll define our variable, let x equal the number. So instead of that simple number, x minus 8, where 8 is decreased by a number, you're taking away from 8 that number, x. So 8 minus x. Okay, so let's just move on. So interest problems. Well, simple interest is equal to PRT. So the interest that you're earning, I, is equal to P, what you've invested, principal. R is the rate that you're investing your amount at, and then T is the time. And maybe you're not investing, maybe you're borrowing instead. So again, I equals interest, P equals the amount borrowed or invested. R is equal to the decimal form of a percent. And T is equal to time. Okay, so let's look at a question or a problem. So it says Wendy, a loan officer at a bank, has $1 million to lend and is required to obtain an average return of 18% per year. If she can lend at the rate of 19% or at a rate of 16%, how much can she lend at the rate of 16% rate and still meet her requirement? Okay. So first my anxiety goes up, and then we can do this. So let's go back through and let's nitpick it. So Wendy, a loan officer, has $1 million to lend. So we have $1 million to lend. And is required to obtain an average return of 18% per year. So she needs a return on the investment 18% per year. So if she can lend either at a rate of 19% or at a rate of 16%. So there's two places that she can lend. She can lend at 18% or 16%. Sorry, 19% or 16%. And our question is, how much can she lend? At 16% and still meet the requirement? Okay, so maybe it's actually better. I don't have these typed out. Maybe while you're writing it out and I'm writing it out, it gives you a time to kind of digest it and maybe think about how you're going to go about it. Well, she needs a return on the investment of 18% per year. What is that really telling us? What is that asking? What is that telling us that we need to do? We can ignore that how much we can invest in each yet. We just need to figure out, and sometimes it's terminology and trying to figure out what they're asking, but she needs return. A return on what? Is it the term right on the amount that she has to lend? Well, let's figure out then what does that mean? 18%. So 18% of 1 million. When you're dealing with percents, you change them to decimals. A lot of times in problems mean multiplication. 18% of, so we're multiplying 0.18 times a million. So I know, well, ignore my decimal. 1 times 18 is 18, and then I would carry all my zeros, but then this decimal would move it over twice. So actually I have 2 less zeros in there. So that would mean that I would have 4 zeros left, which means it's 180,000. So we need a return. Which means she needs that the interest that she's getting back on lending this money so the interest that she needs to get back is $180,000. Okay, so thinking about the formula that we have, we know that interest is equal to P times R times T. But in her case, she has two different ways that she can do this. So we can look at the interest that she gets on the 19% plus the interest that she's getting and making on the 16%. Yeah. So we know that $180,000, which is our interest, has to equal some PRT here plus PRT. Okay, so it's the principal, how much they've invested, times the rate, times the time. Well, I know what the rate is. I know that they're lending at 19% and 16%. So maybe we can write that in there for rate. 19% is 0.19 on average per year. So time is 1. I still need P in here. Maybe call it P sub 1. And the other one, P sub 2, I don't know how much I'm investing yet in here. I have the 16%, so 0.16 times the number of years, which is 1. So we're almost there, where we almost have the equation. Well, the total amount that they have to invest is $1 million. And so I can put part of that million in one account, and I can put part of that million or lend it to another account, or Wendy can do that. And so you just need to choose a variable. And so what about X to be the amount from one of those accounts? And since our question is how can lend, that should be how much can be lent. Sorry. So let us have X equal that amount. So let's say X is equal to the amount invested at 16%. So down here on our equation for P sub 2, let's change that to X, because that's how much we put in that account. So if that's the case, then we can figure out how much they put in to the account at 19%. So for instance, if they put $500,000 into the 16%, we know they put the rest, which is $1 million minus the $500,000 is another $500,000. So $500,000 would have to go in the 19%. If they put $1 in the 16%, we would subtract that from the million, and that would mean the rest, the $999,999 would be in this one. So a way that we can express that is the $1 million minus the X amount in the other. Okay. So this piece at 19%. So the amount is 1,000,000 minus x. So let me put that right in here. And so we came up with an equation so that we can figure out how much Wendy, you, I, they, whoever is wanting this information. I guess us. Okay, so we have an equation, we want to simplify it. So we simplify each side. So we have 180,000. I'm distributing my 0.19 to my million. So this is equal to, that's just going to give me 19, and it's going to take away 2 decimals, 190,000. Distribute your 0.19 to the negative x, so minus 0.19x plus 0.16x. So notice that this is a linear equation. So we are going, well, we're still not simplified, but while we're simplifying, let's move over that 190,000. And then let's combine those terms with x on the right-hand side of the equation. And so if we do that, we get back 190,000 subtracted from 180,000 is negative 10,000 is equal to, and then a negative 0.19 plus a 0.16, larger number, absolute value, subtract the other, that's that's 0.03, and it's negative x. So divide both sides by negative 0.03. And so technically, I probably should be able to do this without a calculator. Dividing with a decimal, I need to move my decimal over twice. That divisor has to be a whole number. And so if I do that, what's underneath the place is going to move this decimal over twice. So I'm basically looking at what is 3 and 2. 6 zeros. In a million. So 3 doesn't go into 1, 3 goes into 10 3 times, that gives me 9. Subtract 10, 10 minus 9 is 1, bring down my next 0, this is 3, that gives me 9. Subtract, bring down my next 0, it gives me 3. So I can see I'm doing a little pattern here, and that is going to give me $333,333.33 approximately. Oops. So we know that this is the amount that needs to be invested at 16%. In order for them to meet the return. Okay, so make sure when you're doing word problems, also make sure that you're putting the units. So if you don't have your units in there, I usually take off a little bit of points. Things are again are going to be a little different though grading. Okay. Let's see. Okay, so that was an interest. So mixture problem. Mixture problems, I tend to like to make tables and kind of organize my information. When you're using mixture problems, that could relate to food, like you're trying to mix nuts and candy together to get a certain cost of a mixture. You could be talking about chemistry, adding chemicals together. So there's different ways that you can look at this. So let's look at a problem and I'll kind of show you how I set these up. We just need to make sure that when we're doing these, this certain unit is equal to a certain unit. So if we're talking about how many pounds we want in this mixture, it has to be on both sides. Or if we're talking about money, then it has to be on both sides. Let's see. Let me just pull one out of here. Okay, so I'm a big coffee drinker, so that this one just caught my eye. It says a coffee manufacturer wants the market a new blend of coffee that sells for $4.10 per pound by mixing two coffees that sell for $2.75 and $5 per pound respectively. What amount of each coffee should be blended to obtain the desired mixture? So again, I don't know about you, but a lot of times, first time I read this, it's like, there's lots of information going on here. Hopefully you don't feel that way, but just go back and kind of simplify it. So let's again go back and read it. So a coffee manufacturer wants to market a new blend of coffee that sells for $4.10 per pound by mixing two coffees that sell for $2.75 and $5 per pound. Okay. So we want a mixture of coffee that sells for $4.10. And we have two coffee blends we're using. One cost $2.75 per pound. And the other one cost $5 per pound. So we want to know what is the amount of each coffee. Used to obtain the desired mixture. Okay, so we got two blends of coffee. Maybe we can call one blend A and blend B. And so let's make a table. And then let's do our new blend is C. So let's put C on that table. So we have a couple of things that we know about these coffees. We know the cost per pound. We're trying to figure out the amount. And then we would have the total cost. So that total cost is we can determine that total cost by looking at how much it costs per pound and how many pounds is there. So for instance, if I have a half a pound and it costs me $10 per pound, I know it's half that cost because I'm only getting half a pound, and so it's $5. So I can get that total cost is equal to the cost times amount. In our case, it's cost per pound times the amount. Okay, so go through and then pick out what we know. So we know that the cost that we want for, or the cost for blend A. So let's say that that was the 275. Doesn't matter. So 275. We don't know how much we're putting in here. So let's maybe call that amount X. And we know then that the cost of B is $5. And we know that our new cost we want is $4.10. We also want to know that cost when it's 1 pound. And so I can say this is 410 all times the amount, which is 1. So this is equal to $4.10. So if I look at the total cost of coffee A plus the total cost of coffee B, the thing is I don't have the amount of coffee that I'm going to use. And so, but I know I want 1 pound of coffee altogether. And so if I look at 1 minus what I put in with brand A, I had to do 1 minus X. And so now I have my formula. So 2.75 times X is the amount it would cost to use brand A. And then I'm going to look at the amount that I'm going to use of brand B. It costs $5 times the number of pounds, which is 1 minus X. So total cost of brand A plus total cost brand B equals total cost. Oops. total cost brand C. Come on. So 275x plus 5 times the quantity 1 minus x. This has to equal 410. So using your distributive property, so you have 275x plus 5 times 1 is 5. 5 times negative x is negative 5x equals 410. Let's combine like terms. I notice it's linear, so let's get the constant on the other side while we combine like terms on the left. So I have a 275x minus a 5x. So you should technically be able to do decimals. 5 minus 275, borrow. So this is 9. 9 minus 7 is 2. This gives me what, 3? 2. 225. And it's a negative. So negative 2.25x is equal to 410 minus 5. So this would be negative 0.90. Okay, I was just doing some of the math because I know that maybe it's a good little review, but I don't want to spend that much time. So 0.9 divided by 0.9 divided by 2.25. They're both negative, so I get back positive 0.4. So that would tell me that, and that I have to go back and look at what x is. So that tells me that they want 0.4 pounds of the brand, and they were distinguishing it by cost. So the brand at 275. So I know if a total, it's 1 pound and it's 0.4 pounds is going to the 275, then I know 0.6. So 0.6 pounds of the brand of coffee at $5. So 2 more types. Uniform motion, and so let's do uniform motion. So uniform motion is telling us distance is equal to rate times time. So distance problems. So distance equals rate times time. So one thing that we have to think about, and you just may be aware of when we're looking at speed, which is rate here, if we're talking about problems where you're in the water and you have current that you're going with the current, so basically the current is pushing you, it's actually making you go faster than what that engine or what you would have been doing if there was no current at all. And then if you're going against the current, then you know that's actually going to slow us down. And so it depends on how fast that current is going. You're going to add if you're going with, and you're going to subtract by the rate if you're going against. So same thing with air current. So you might be going against the wind or with the wind. And so if you're dealing with that with rate, then we have to think of the rate as the rate without that current or wind plus or minus how fast the current or wind is going. Okay, so that being said, let me grab a problem. Okay, so who doesn't like a moving walkway? Or if you're like in an airport and you're trying to get someplace pretty fast and you're carrying all your luggage, it's so much easier to get on one of those walkways, right? So, and that will make us get to where we want faster, and you don't have to carry all that stuff as long. So let's look at the following problem. Plus, if we're in an airport, hopefully that means we're traveling, which is even better. Okay. The speed of a moving walkway is typically about 2.5 feet per second. Walking on such a moving walkway, it takes, I'm going to say you or I, a total of 48 seconds to travel 50 feet with the movement of the walkway and then back again against the movement of the walkway. What is your normal walking speed? Okay, so going back through, says the speed of the moving walkway is typically about 2.5 feet per second. So we have a walkway. That's actually one word. And it moves 2.5 feet per second. Okay, so you're walking on the walkway. It takes a total of 48 seconds to travel 50 feet with the movement of the walkway and then back again against the movement of the walkway. Okay, so 50 feet on the walkway. Um, 50 feet on the walkway. Going with and back again. Okay, so maybe you and your friend are playing a game and waiting for the plane to get there, and they tell you, I want you to go walk on the walkway with it, and I'm gonna tell you to turn around and get back to me at a certain point. And so you walk on the walkway and your friend tells you to turn around, come back to you at a certain point, and so you're running against or walking against the walkway. It's slowing you down, coming back, and you find that it took, what did we say? 48 seconds. Okay, so we got two things. We got with the walkway, and we got against the walkway. We got time, we got distance, and we got rate. Maybe I didn't set this up the best, but it's okay. Okay, so we know the total time is 48 seconds. How can we do this? So we want seconds to equal seconds. We need to figure out how far they went with and how far they went against. Well, if they started at one point, or if you start at one point and you walk with the walkway and you turn around and you come back, wouldn't you be doing the same distance? So we know that the distances are the same. So we know the total distance together is 50 feet. And we have against and with. So, well, if the distances are the same, I can reason that this is half the distance, which is 25 feet. Is that what they said, 50 feet? That's where it might mean when I'm going back and rereading this. So it takes you a total of 48 seconds to travel 50 feet with the 50 feet with the movement of the walkway, and then back again against the movement of the walkway. So question for you guys, are you taking it as that is the total is 50 feet there and back? Now I'm going back and I'm rethinking that. This to me is maybe 50 feet. You're going 50 feet with the walkway and then 50 feet back against the walkway. And so if that's the case, then that changes a little bit, right? My eraser's not going to work. Now my computer's kind of slowing down. So you think somebody think it's both connections combined? I mean, okay, so if that's the case where it's both, if we believe that, which I was reading at first, then this would be 25 feet and this would be 25 feet. Okay, we don't know the rate, and that's what we're trying to figure out is how fast are you walking? And so we need to have a variable, and so maybe R, because we're trying to find R. So maybe R, let R equal the rate of walking or running off of the walkway. So that means if we're going with a walkway, we have the rate that we normally walk plus the piece that is pushing us, which is 2.5 feet per second. So plus 2.5. And if we're going against that, then the rate is R minus 2.5. So distance equals rate times time. We know we have a total of 50. Let's see. Let me do this.
Wouldn't the R plus 2.5 and minus 2.5 be under rate, or am I wrong?
Yeah, I just noticed that too. I'm like, okay, I need to change that. So let's just change that so I don't have to erase the other piece. Maybe. So this is our rate. And so this would be our time. And no, I'm a little stuck. Okay, so time we know is total time. Total time is 48 seconds. Total distance is 50. And we're looking at the okay, so let's pause this for a second and think about it. Okay, so this is where we would like to use the fact that if we have an equation and we're trying to solve for a particular variable, and if this one distance equals rate times time is not in the form, we're trying to look at time right now. So let's, if we know what time is, we can find the other. Wait a minute. So we know that time is equal to, if I look at my distance equals rate times time formula, if I divide by r, I know time is equal to distance divided by r. Everybody agree? And so basically, with the walkway, I can rewrite this in terms of time. So time is my distance traveled, which is 25, all over the rate I was going, which is r plus 2.5. And so if I look at the time it would take me to travel against the walkway, it's my time, my distance, which is 25 feet, all divided by the rate, r minus 2.5. So wouldn't you agree, if I look at, and the total time was 48 seconds, I'd have to look at the time I went walking on the walkway plus the time it took me to walk back. And so, and we know that total time is 48 seconds. So let's sum those times. So we know the time with the walkway, which is 25 all over our, all over r plus 2.5, plus the time coming back, 25 all over r minus 2.5. We know that this was 48 seconds. And so now we need to look at solving this. So really, the hardest part of these things is usually setting them up. So we have all the tools from earlier this week to solve this. We have a rational equation. We want to get rid of the rational equation. We can multiply both sides by our common denominator. I'm actually, to save some time because I want to get through another one, we would you're going to multiply by your LCD, which is r plus 2.5 and r minus 2.5. Actually, now I don't want to do that. Let's maybe quickly go through it. If I multiply every single term by that, notice my r plus 2.5 cancels in the denominator with the r plus 2.5 here, and we're left with 25 from my numerator, all times this r minus 2.5. So 25 all times what was left after it canceled, r minus 2.5. Plus, so when we distributed the LCD to the second fraction, the r minus 2.5s cancel and you're left with 25 times the quantity r plus 2.5 is equal to, so we have 48 all times, well, unfortunately nothing cancels there, but I noticed that that's a difference of 2 squares factored. So that's r squared minus 2.5 squared. So r squared minus 2.5 squared, which is 6.25. So let's distribute our 25. We have 25 times r is 25r. 25 times 2.5 is 62.5, so minus 62.5, plus 25 times r is 25r. This is going to give me plus 62.5 is equal to 48r squared minus 48 times 6.25. Which is 300. Okay, so we have 25r plus 25r. That's 50r. We have a negative 62.5 and a positive 62.5. Those cancel. Is equal to 48r squared minus 300. So we have a quadratic equation and we can get everything to one side. So we have 48r squared minus 50r minus 300. I subtracted 50r on both sides equals 0. I hate that those are huge numbers, but a lot of times math is not always pretty with numbers. So we have x is equal to negative b, 50, plus or minus the square root of negative 50 squared, that's 2,500, minus 4, I'm going to do it right now, times 48 times 300. There's 2 negatives, so that's plus. Is 57,600 all over 2 times 48 is 96. So 2,500 plus 57,600 is 60,100 all over 96. So 50 plus the square root of that answer. Take that result and divide it by 96. So x is approximately, and I didn't round anything until the end. And I should have r there. So this is approximately 3.1. And it is feet per second. If we looked at the square root of 60,100, that is that's 245. And I notice when I take 50 minus that, I'm going to get a negative number, which doesn't make any sense. And so I don't even have to worry about that one. Okay. Okay, so we have one more type. And so the next type is a work-related, or they call it a job problem, a rate of job problem. So these are the type that you're either talking about somebody doing a job or a machine doing a certain type of job. So these are the type of problems where it might take you to do a certain number of hours to clean the house, where it takes your sibling a lot longer to do the same job. And then your mom wants you to clean the house together with your sibling. And so how long would it take you guys to do it together? Or you're so hot outside and you just bought a little mini pool to cool down, and it takes one hose a certain amount of time to fill a pool and another hose a certain number of time to fill a pool. How long together? Or both of them, we know together fills this much. How long would it take just the one hose to work? Okay, so that's what we're looking at. And with these problems, the best way to set these up, I found, is 1 over, because it's one job, over the time it takes one person or one machine or hose or whatever you're talking about. So 1 over the time for one thing to do it, plus 1 over the time for another thing to do the same job. And we can do this if there's even more than 2 people or hoses or whatever we're talking about, is equal to 1 over C, the time it takes to do it together. And so, pulling a problem out. Okay. So Patrice, by himself, can paint 4 rooms in 10 hours. If he hires April to help, they can do the same job in 6 hours. If he lets April work alone, how long would it take her to paint 4 rooms? Okay, we got 2 people. I don't know if I'm saying this person's name right, so I apologize to this person who doesn't probably exist. So Patrice, 4 rooms takes 10 hours to paint. Patrice and April together can paint, what did I say? Can paint in 6 hours. How long does it take for April to do the job on her own? Okay, so we know 1 over the time for one person, which is 10, plus 1 over the time for the other person. Well, we don't know that, so let's put that x. So I'm going to define what x is. X equals the number of hours for April to do the job. And we know that this is equal to 1 over the time for both of them to do the job together, 6. Okay, so we've already dealt with this type of problem, a rational equation. We can clear the fraction by multiplying by the LCD, try to figure out the smallest number 6 and 10 go into. I think it's 30, and then we also have the x, so we have our LCD is 30x. So technically, if we go through and we multiply each term, we can do this because it's an equation. on each side of the equation by 30x, our fraction would go away by canceling and reducing. So we have 30x over 10 is just 3x, plus 30x over x, that gives us 30, plus 30x over 6, that gives, not plus, equals 5x. So this one isn't bad. This is a linear equation. Get x by itself. We could subtract 3x. We get 30 is equal to 5x minus 3x is 2x. Divide by 2, we get x is equal to 15. So thinking and looking back, if it takes them 6 hours to do it together, well, and him 20 or 10 hours, that seems about right. Or in terms of hours. Okay, so we made it. We did chapter 1. Chapter 2 actually might be a lot easier than chapter 1. So, and chapter 2 is going to go a lot faster. Let me look. But there's not as many sections in here. And so I might be able to accomplish my goal of completing chapter 2 by the end of this week. So I know we have 11 minutes left. I would love to stop here, but I'm not going to. Just let's go real quick over 2.1. It's going to go really fast, or at least part of it. So 2.1, basically all you need to remember is how to plot points. So that's really easy, right? Hopefully. You got your x-axis, you got your y-axis. Your points are always in the form where your ordered pair, your x value coordinate, comma, your y coordinate. You have 4 quadrants that are broken up by these axes. On the upper right hand, you have the quadrant 1 represented by the Roman numeral 1, which looks like an I. Counterclockwise, you got the Roman numeral 2. Down bottom left is 3 and 4. So it's important that you know the values of your points in these quadrants. And those of you who are taking trig this semester with me, this we're going to see and use this all the time. But basically, we know our x value, or hopefully you know the x value in quadrant 1 is positive, and your y value in quadrant 1 is positive. And then here on the left in quadrant 2, our x value is actually negative and our y value is positive. Quadrant 3, negative, negative. In quadrant 4, x is positive and y is negative. So if we want to look at the distance between 2 points, basically we can derive this really quick if you remember your Pythagorean theorem. Basically that says if you have a right triangle, so the sides of the triangle that is not the hypotenuse are called your legs. So A and B are sides, our hypotenuse, let's call it C. This says that if you sum the square of each leg, this is equal to the square of the hypotenuse. Okay, so let's say we have 2 points. So let's just arbitrarily call them. So let P sub 1 be 0.1. And let's say that this is equal to X sub 1, Y sub 1. And let's say we have another point, 0.2. This is equal to X sub 2, Y sub 2. Okay, so you're going to arbitrarily draw where those points are. So you're going to find where they are. So let's say right here, this is X sub 1, Y sub 1. And let's say this right here, it could be below, but right now my picture is above. This is X sub 2, Y sub 2. So if I want to find this distance, I want to find this length that joins these 2 points in the straight line. So we can basically draw a triangle, and we can make it so that it is a right triangle. Well, if we want to figure out what the distance is of that base of the triangle, this x value right here, this x value is X sub 2. This x value right here is X sub 1. So to find the distance, and maybe X sub 2 is actually smaller, so we're going to actually put absolute values in here. We can look at the larger number minus the smaller number. Or if it was the smaller number minus the larger number, then when we take the absolute value, it would be positive and we'd be okay. So this is this length in here. And then we can do the same thing with the height. And so if you look at this y value in here was y sub 2. This y value in here, if you looked on the x and y axis, this was y sub 1. And so to find that distance between the two, we can think of it as an absolute value of that change from y sub 2 minus y sub 1. So by Pythagorean theorem, we know that this hypotenuse, let's call it d, this distance, that distance squared is equal to this distance, so x sub 2 minus x sub 1 quantity squared. So technically, because I'm squaring that number, I don't technically need those absolute values in there anymore. It doesn't hurt if you put them there, but basically when you square a number, it's going to become positive. And then it was plus the distance or length of the other side, which we said was y sub 2 minus y sub 1, quantity squared. So that's just the Pythagorean theorem. So if we take the square root of both sides, we can get what this length is. So the distance between those 2 points is the square root. I am not putting in the minus there because we're talking about distance. Is equal to the square root of x sub 2 minus x sub 1 quantity squared plus the quantity y sub 2 minus y sub 1 quantity squared. Okay, so basically giving 2 points, you're just kind of plugging and chugging, plugging in those values for your points into this formula, and that would give you the length between those distance. One more thing, and then we're done. So the midpoint, and I won't derive this formula, but basically the midpoint is the halfway point between both of those 2 points. Think about it, halfway, kind of averaging. It's halfway between 2 points, or 2 values, you're averaging halfway. So that's kind of how I think of it. And so the midpoint formula for 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. We're summing our x values and trying to find the halfway point between there. So divided by 2, comma, y sub 1 plus y sub 2 all over 2. So if you want to find the halfway distance between 2 points, there you go. So this little bit here might be helpful when we talk about circles tomorrow. Okay, which also should be review. You guys are doing awesome. You did it. We did it. Let me take a picture and figure out who is here today. Let me pause.